So today's topic is the data modeling, guys. So data modeling is a way to design the model of the data in data warehousing. So as you know, there is a data model which has to be decided by the data modeler or architect to keep the data. Okay. In the normal, if this is a simple database, then there is something called as entity relationship diagram. There's one table which is joined to one table, or one table joined to many table. Many table is joined to many table. That is entity relationship diagram. That is in the normal database. But when it is a data warehouse system, the data modeling, a data modeler has to think and is a very highly technical person, data modeler or data architect. Once we work for at least 10 years, 12 years, then this position is given based on the skill set of the person. If he's really good, then he gets a position of data architect or data modeler. Testing team or development team, this person gets this particular position. So what happens in data modeling of data warehouse system is this, that the entire data, whatever transactional data we'll get. So as I've already told that the data in the data warehouse is integrated data. So what happens, the entire data is divided into two types. One is what the fact table and another is the dimension table. There is only two tables. That is a good way in data warehouse modeling. There's only two tables. One is the fact table and one is the dimension table. So these are called as what? Fact and dimension table are denormalized. You know what is the meaning of denormalized is what? Denormalized means what? Data from different tables get integrated into one table. That is called as what? Denormalization process. So all fact and dimension table are denormalized. Okay. Denormalized means what? Smaller tables will be joined to form a bigger table. That is called as denormalization. And normalization is splitting of larger table into a smaller table, as I've already discussed. Here, what happens? Fact and dimension tables are denormalized because small table will get integrated. So it is what? Denormalized. There are only two kinds of tables. Always remember fact and dimension table in any data warehousing project. Fine. Now, guys, the thing is, next thing is that we'll understand what is a fact table, also called as transaction table. Okay. So this fact table or transaction table is the primary table in their dimensional model. The fact table consists of the measures or the facts. As you know, measures are also called as measurement. These are very key factors, also called as measurement or facts or that. So this is what a very numeric type of thing, measurement or measure of fact. So what happens here is, guys, in measurement or fact or measures, what happens, guys, is the numeric values are stored. Okay, this is not a generic value, this is a numeric value. Okay, so what we can do is the measurement or the fact or the measure value, like suppose I tell the sales of a particular project, so that is nothing but your measure or measurement or facts. So that is nothing but your nothing but a numeric value, measurement value. If I measure that how much sales is happening for a particular product or what is the quantity of the product, that is nothing but your the measurement or the measure or fact value in a fact table. And again, this fact table also consists of the foreign key. Okay, so there are two kinds of keys, as I've already told you. The master table will always have the primary key, and the child table or slave table, or also called as what transactional table, will always have the foreign key. That means, guys, these questions needs to be completely understood because it is asked, as well as we should know that foreign key will be there in the fact table. That will be joined to the dimension table primary key column. Primary key is in the surrogate key column. So this concept should be very clear. Two things. First is the fact table will have the foreign key. Okay. So easy way is F is the fact. Just to remember, F is the foreign key. The fact table will have the foreign key. Dimension table will have the primary key. Now primary key from the dimension table, which will be in the surrogate key, that will be joined to the fact table, okay, foreign key in the surrogate key, and then this parent table primary key, which will be dimension table, will be joined to child table, fact table, foreign key column. This is how the joining will happen. Fact table will consist of the fact values, numeric values, measure value. All these things will be in the fact table. Now, now next thing is dimension table, also called as master table. Okay, so we should always remember that. So it is also called as what? Dimension table is also called as master table. So it consists of the description of a fact. That means what? Suppose a sale is happening, okay, for a particular product for a particular year, is suppose 10,000 rupees sales is happening, for an example. Now that particular sale is happening for a particular product ID, that is fine. Now this particular product ID and this particular cell is given in the fact table. But now guys, we have to know what is that product name, then what is the product description. So all this kind of details, that like product name, product description, product size, product quantity, not quantity, product quality, all these things, which is a descriptive kind of value, will be present in the dimensional table. So it consists of the description of the fact table. Okay, so always remember, it is always a descriptive value. Product name, okay, product design, all this kind of things, product length, these kind of descriptive values are there in the dimension table. But fact table only consists of fact value. Also it consists of the key columns, which will be joined to the dimension table. So now dimension table is joined to fact table via foreign key. As I've already told, that dimension table will consist of primary key, fact table will be consist of foreign key. This primary key and this particular foreign key will be joined. Dimension tables are again denormalized. As I have already told, fact and dimension are denormalized. Why denormalized? Because the tables are getting integrated and then it is going into dimension or fact table. So this is what is a denormalized table. The dimension attributes are various columns in dimension table. Okay. So now in the dimension table, there will be dimensional columns where the description of the particular facts will be given. So next is the description, descriptive values of the fact are given in the dimension table. This is fine. So there is no set limit for a given number of dimensions. There can be any number of dimensions, guys. Always remember, the number of dimension tables and the dimensional values can be any number. There's no set number of dimension. And then dimension can also contain one or more hierarchical relationships. That means what? There's a location dimension. It can again be further divided into location hierarchy. So item is there in a dimension table, then again it can consist of item hierarchy. So it can have the hierarchical relationship. After this fact and dimension, let us have parameterized it and did a completely detailed differentiation, because many people are getting confused in fact and dimension table. Let us just understand. First is the definition by parameters. So fact consists of the measurement matrix or fact about a business process. Dimension table, comparison table or companion table to the fact table contains descriptive attribute to be used as querying, constraining. That means what, guys? Simple fact table consists of the measurement or fact values which are used in the business process, and dimension table will consist the descriptive attribute, and we can query this fact and dimension table by joining this. We'll see again how we are joining. Next consists of the characteristics. So characteristics fact table, if it is there is something called as data model, star schema and snowflake schema, which we will discuss. So here you will see that fact table is always one and always in the center, okay, in the star schema and snowflake schema. But dimension table are many and they are in the edges of the star or snowflake schema. I will show you how. So next is the design. So designed by their grain or its most atomic value. So fact table will have the defined. If we define a fact table that is based on the grain or is almost atomic value. Grain value means the lowest level of division what we can do. That is nothing but your grain value. Suppose a particular product is there and a particular sale is happening. So for the product ID, that will be the lowest level of division. So that is nothing but your grain value. That is how fact tables are defined. But for that is how the fact table are designed. But for the dimension table, it should have the descriptive and the complete and quality assured. Okay, it should have the complete descriptions and all should be given for the dimension table. Now it come to the task. So fact table is a measurement event for which dimension table data is collected and is used for analysis and reporting, whereas dimension table collection of reference information about the business. So dimension table is just the reference information about the business, and fact table is the measurement event for which dimension table data is collected, okay, and is used for the analysis purpose. Types of data. So fact table could contain information like sales against a set of dimension like product and date. And the dimension table contains attributes which describe the details of the dimension. Like example, suppose the product dimension can consist of the product category and the particular product ID, etc. All these particular detailed informations can be there in the dimension. So fact table consists of the foreign key value, and dimension table has primary key column that is uniquely identify each dimension. So storage, it helps to store the report label and filter domain values in the dimension table. And with respect to dimension table, is loaded detailed atomic data into dimensional structures. Hierarchy does not concern structure, and fact table can have the particular hierarchy. I told you location can have location, hierarchy and all. Apart from that, always remember whenever data is loaded, first the dimension table will be loaded, then only the fact table will be loaded. So primary key column will check the values. If the data exists, then it will compare with the primary key column data. If it exists, then it will be loaded in the fact table. If the data does not exist, it will not be loaded into the fact table. So always first dimension table is loaded, then only the fact table is loaded. So this is what is the fact and dimension table. So fact table consists of measurement, numeric, and very less textual information. Textual means very little description, like product ID and all can be there. But dimension table can only have the textual data, only descriptive values. Fact table will always have the less number of columns, but dimension table will always have the more number of columns, because fact table will mainly consist of the fact measurement values and the key column which will be joined to the dimension table. So that is nothing but the less number of columns, but here there will be always more number of columns. But the fact table will always have more number of rows, because we'll have the sale for per day, and then the number of rows will increase. But dimension table will have less row, because the product description, product name and all does not require so many records. Once we have written, that's enough. Fact table is also called as vertical table because the number of rows are increasing. Dimension table is also called as horizontal table as the number of column increases. So fact table primary key is combination of all the primary key from dimension table. Primary key is a surrogate key. See, this is a point which is depends on the data modeler. But dimension table will always have a primary key which is a surrogate key, and fact table will have foreign key, which is a surrogate key which can be joined. Okay. Now the next is this the primary key in fact table. The four foreign keys are there. Now adding this 4 foreign key can become a primary key in fact table, or data modeler can define a particular column as a primary key in fact table. So this is first is the dimension table loaded, and then the fact table is loaded. So overall, guys, what I will tell you, whenever someone will ask you the difference between fact and dimension table, you tell that fact table consists of fact value, numeric value, measurement values, and the key columns, which is joined to the dimension table. Dimension table is the parent table, which consists the description of the fact table. It consists of the primary key. Fact table consists of the foreign key, which is joined to the primary key. And then the dimension table always the number of columns are more, so it is called as horizontal table. In fact table, always the number of records are more, so it is called as vertical table. A dimension table consists of descriptive value. Fact table consists of what? Numeric or the measurement value. That is what the overall gist of this differentiation between the fact and the dimension table. Sometimes this is a very, very theoretical thing, types of dimension and fact table. But first you have to tell the definition, guys. Never ever explain this, because this explanation is a huge explanation. Always the definitions are asked like, what are the types of dimension table? So you should tell what there is something called as conformed dimension, or someone will ask you what is a conformed dimension. So conformed dimension is a dimension that is having the same meaning and content when being referred with from different fact tables. That means what? Suppose a time dimension is there, so any fact table, it will have the same meaning only, because time is a dimension which will have the, whether it is a sale of a product or a sale of a particular different product, or revenue of a product, everywhere the time dimension will be same. So time confirmed dimension is a dimension which can be joined to all the fact table, or we can tell it simply, confirmed dimension is a dimension. Simple words you can write down. Confirmed dimension, it is a dimension, okay, which has same meaning to all the fact table. You can write like this, or you can tell is a dimension that has exactly same meaning and content when being referred from different fact table. Example is time dimension. That's all you have to tell. The dimension table which has same meaning to all the fact table, and example is time dimension. That's all you have to explain. Next, detail level also I will tell you, but first you have to tell what is a dimension which has same meaning through all the fact table, like time dimension. That's all. Next is the degenerated dimension. So this is the dimension, is the dimension key in the fact table that does not have its own dimension table. So now this degenerated dimension, what happened is a dimension key in the fact table. This is a key column in the fact table, and that does not have its own dimension table, like order number, invoice number, purchase number. So now what happened? This order number is in the fact table, okay guys, but a particular order number column is not there in the dimension table. So that is called as degenerated dimension. What happens in degenerated dimension is there will be a fact table. Now fact table will have the suppose sale of a particular product, so it will have the order number, suppose order number 1 2 3 4. So now what will happen, guys? This 1 2 3 4 is a dimension key, okay, and now this dimension key is present in the fact table, but it is not present in the dimension table. So if the dimension key is only present in the fact table and it's not present in the dimension table, that is called as degenerated dimension. Example you have to remember, like order number, invoice number, purchase number, all these things. What will happen? This key column like order number, invoice number, purchase number will be in the fact table. Okay, this is a dimension key, but it is in the fact table, but it is not having its own dimension table. Are you able to understand? Degenerated dimension means what? Is a dimension key in the fact table, and it is not having its own dimension table. That means dimension table is not there for this particular dimension key, and it is present in the fact table. This is just the opposite. This dimension key is present in the fact table, which is not present in the dimension table. Example, order number, invoice number, and purchase number. Dimension, guys, now dimension key and key columns we will see, we'll understand what is this key column and all when we will learn the star schema and snowflake schema. Next is, guys, okay, so next is, guys, is the junk dimension. The junk dimension is a collection of random transaction code, flags, and text attributes that are unrelated to any particular dimension. Example, payment mode, cash, credit, okay. So now next is what, guys, is the junk dimension. So now this junk dimension is what happened. See, if a random code flag is there or text attributes are there, and they are unrelated to any of the dimension. Okay, this is not related to any of the dimension, guys. So what happened, we are collecting this random transaction codes in a particular dimension table that is called as what, junk dimension, but that are not related to any particular dimension. Okay, but we are just collecting that transaction code flag and text attributes, and that are not related to any dimension, particular dimension, that is called as junk dimension. Junk dimension, what happened, is a collection of random transaction code. Some random transaction code flags are there, some random text are there that are unrelated to any particular dimension and this related fact. But what happened, these are there. If this kind of random transaction code flags and text attributes are there, they are put in a particular dimension called as junk dimension. So I told you guys three kinds of dimension. One is what, conformed dimension. So conformed dimension means a dimension like date dimension, which has the same meaning across all the fact table. Next is degenerated dimension. Degenerated dimension means what, is a dimension key in the fact table that is that does not have its own dimension table. Key column, the key dimension key means what, guys, there's a key column that is nothing but your order number column is present in the fact table, but that particular key column is not having its own dimension table. That is nothing but degenerated dimension. Junk dimension is a collection of random transaction codes like flag text attributes that are unrelated to any particular dimension. That means junk dimension means what, guys, a collection of random transaction codes like code flag and text attributes that are unrelated to any particular dimension. This kind of things are collected in a particular dimension called as junk dimension. So let us just understand in detail, guys. If again someone tells you, can you explain in detail? First, you have told what, conformed dimension is a dimension which has same meaning to the all the fact table like date dimension. That's all. If still someone asks, then understand this. Now this is a particular time dimension table. Okay. Now this time dimension table is a fact table. Let me just come here. Let me just finish the data modeling part. Okay. So understand, guys, the data modeling is types of dimension and types of fact. We'll understand once we complete the data modeling. So data modeling is having three kinds of generally data models are there. This question is oftenly asked, which is the data model asked used in your particular project? Generally star schema and then snowflake schema. Okay. So first is the star schema. So let us just understand a star schema, then we'll understand snowflake schema. So what is a star schema? So star schema is what, guys? Fact table is in the center, okay, and then dimension table has been in the edges. So this is called as what? Star schema. The overall the model is looking like a star because fact is in the center and on the edges the dimension table is there. The model is looking like a star, so its name is star schema. Okay. So that is called as what? Star schema. Now here see, let us focus on these particular diagrams to make it more clear. So tell me which is the fact table, guys, here? Which is the fact table?
Center one.
Yeah, order table is the fact table. Okay. Now if you see carefully, guys, this order table is the fact table and this state table is the dimension table. So these questions are asked. Can you tell me in your project which were the fact table and dimension table? So you can just tell. In my project, the data migration project, this is the order is the fact table and state, salesperson, and customer and product was the dimension table. Fine. This is a star schema because the structure looks like a star schema. What is a star schema? A fact table surrounded by multiple dimension table is called as a star schema. Since the model resembles to a star, it is called a star schema. And then if they ask what are the fact and dimension table in your project, so order is the fact table and state and the salesperson and the customer and the product is the dimension table. Let us understand the key columns and what is the key column and all. So first, guys, understand in the fact table, there will be, I told you, there will be fact value or measurement value or numeric value. So what are the fact value here? Order amount and order quantity. So order amount and order quantity, I can take this sum of the order amount, sum of the order quality, that is nothing but quantity, that is nothing but your numeric value. There is key column. Which are the key column, guys? As you see, state ID, this is a key column. Salesperson ID, this is again a foreign key. Product ID, this is again a foreign key. Customer ID, this will be again a foreign key. Now, is it clear? These are the foreign key and these are the numeric value or the measurement. Am I clear, guys? Everyone, Shama, did you understand this much? Order amount is a numeric value or a measurement value, Ramya. Order quantity is a numeric value or a measurement value, and all these are key columns. Am I clear? Tell me yes or no.
Yes.
So now these are the dimension table. So which tables will be loaded first, guys? Dimension table or fact table?
Dimension table.
Dimension table. That means this state table, salesperson table, customer table, and product table will be loaded. And this table, suppose a sales table will have which column, guys? Primary key column or not? Tell me yes or no.
Yes.
Yes. So this salesperson ID will have this primary key column. It will be joined to which column, guys? Salesperson ID of the foreign key of the fact table. Yes or no, guys? Yes.
Yes.
So this is one key column. So how this table will be joined? Can you tell me state table? Which is the primary key here? State ID.
State ID.
This ID will be joined to which state ID of the fact table?
State ID of foreign key.
Yes. Similarly, for product, it is a product ID will be joined to this. Customer, this is a customer ID, this will be joined to this. These are called the key columns and the numeric value. Fact table consists of what? Key columns and the numeric or the measurement values. So this is fine, guys. So that is what is the thing. Okay. So these things I already told you. The most primary key is a surrogate key. Okay. So primary key is the what? This surrogate key column here. Primary key is a combination of this foreign key. Okay. And these things I have already told. Now let us just focus here. Suppose, guys, the question is asked analytical queries. Find out the sales amount by state name. Okay. That means we have to find out the sales amount. That means what, guys? Sale of the amount by state name. That means what, guys? The sales amount will be in which table? Order table. Now I want the sales amount. So what is that? Sum of the order amount. From which table? Fact table. And for which state? For the state wise. Then I will have to join with which table, guys? Dimension table. And group it with what? Group by the state name. This is how the fact and dimension table is joined. Let us just see what I did is. First I will take what, guys? Sum of the order amount. Which are the sum of the order amount? This I have got the. What is the question? Find out the sales amount. Sales amount will be what in the order amount column. So I have taken the sum of the order amount. Now what I taken, guys? I wanted what? Sales amount by state name. Now, guys, state name. That means I have to group it with what? Group it with the state name or not? Tell me yes or no.
Yes.
Yes. So what I will do, guys, tell me. I will have to group it based on what? Based on the state name. So that means what, guys? I'll join these two table and then I'll group it based on the state name. So suppose I wanted to write the query. What will I write, guys? Is select. Can you just tell me sum of what? Order amount. Okay. Now state wise. So state name. Let me just take the name of this particular as a fact table. So I've written F. The dimension table I have written what? D. Now from which table, guys? Can you just tell me? From which table? Order table.
Order table.
Yeah, order. I have written F. Okay. Suppose I write left join. Generally, I do see. When we write join, what will happen, guys? Only matching record. And when we write left join, matching record from right table, matching and non-matching from the left table. If we want to use equi-join, what happened? Number of record reduced. So in real time, generally people uses left join or equi-join. So as of now, we'll use left join because I don't want to reduce the number of records. So order F, left join. Now what is the state table name? What is the dimension table name? Can you just tell me? State. So what will write, guys? State D. On what, guys? F dot. Can you just tell me how to join this two table? F dot what? State ID.
State ID. equals to
E dot
state ID,
state ID, and group by what, guys?
product
State name. Okay, so for a particular state, what is the
name.
particular sale? Yes or no, guys? Yes.
Yes.
These are the things, guys, you have to understand that how we analyze a particular way to join a fact and dimension table, and how we analyze a particular fact and dimension table, how we join it, and how we do it. Am I clear, guys? Tell me yes or no.
Yes. Sir, in an interview, so they will ask a theoretical question from model that data modeling.
Yeah. That we'll discuss separately, that which are the fact table, which is the dimension table, how were you joining this. So you will tell us this particular order table I have to join with the all this 4 fact table. Okay.
Okay.
Which is the dimension model used, you will tell star schema, snowflake schema, those things I'll tell you. Okay. So this is guide, find out the sale by country and state. So can you just tell me country and state, how can I get country? I can get from which table, guide? No, sale by country and state. So country I can get from where? Not sale by country. I think sale by customer and state. So how can I get the customer and state? Can you just tell me? Customer is from where? This is not
customer.
Yeah, sorry, this is not the way. Okay. It should be your question is what? 1 second. Find the sales by country and state. Can you just tell me the query, guys?
Customer and state.
Yeah, customer and state. Can you just tell me how can we get this customer and state? Can you tell me the query, guys? Customer and state. First, I have to get what? Sales. How can I get sales, guys? Tell me. Select sum of order quantity. Yes or no, guys? Yes.
Sum of order amount.
Tell me. Select sum of order. Okay.
Amount.
And from what? For a particular state and customer. So state is fine. Now what I want, guys, is this is why this is coming. Hold on. This is a separate query. Yeah. From here, tell me what will happen. Select this is select the sum of the order quantity, comma d dot state name, and also I want what, guys? Customer. So I will write what? Suppose D1 I have given D1 dot what? Country. Country. No country. Is this country or customer, guys? Customer. Why I am written customer? Yeah. D1 dot customer. Okay. From what happened? This table is joined to this table on this basis, and then what you again you have to join. What will write, guys? Can you just tell me? Join. What will happen? Again we have to join what? Which table? Which table? Customer table. So join customer. What, guys? I have written name is as what? D1. On what will happen, guys? F dot. What is that table joining condition in the customer table? Customer ID. F dot customer underscore ID equals to what? D dot customer
ID.
And guys, group by what, guys? Can you just tell me?
Group by customer.
D dot state name, comma D1 dot
by customer.
Yes or no, guys? Tell me yes or no.
Yes.
This is what is the how the fact and dimension table is there. Okay. There is also the same thing. Group by what? He wanted for a particular sales person, person name also. So group by sales person name, customer name. Whatever column you want, you can just take in this select and you can just get it. Yes or no, guys? Yes. If I wanted for a particular state, I can get it. If I want for a particular salesperson and customer, I can join these 2 table and get group it based on that. Yes or no, guys? Tell me yes or no. Are you understanding?
Yes.
This is what if I want a particular for a particular salesperson and also for a particular customer. So what I have done, I have taken all these columns here and then group by what, guys? Group by what? group by salesperson and customer name. Yes or no, guys? So whichever dimension table I want to join, and based on that I can prepare my query. Yes or no, guys? Are you understanding? Tell me yes or no.
Yes.
This is this is again snowflake schema. You again have to understand this one. Here what happened? Dimension table is further normalized. So what happened, guys? Star schema means what? One fact table surrounded by multiple dimension table, and snowflake schema means what? Dimension table is further normalized. Normalized means what? Larger table is split into a smaller table. That is called as normalization. That means what, guys? This is same fact table is only one. Remember that snowflake star schema fact table is only one. Now here this is a dimension table. Now dimension table is fine. There is something called as now in the dimension table there is something called as what, guys? There will be location, there will be location, the location hierarchy, and all those things will be there. Okay, this is fine, guys. Now what will happen? This product table is again further divided into variant table. Okay, so like that. Okay, what will happen is further normalized. Suppose there is something called as the location table. Now what will happen? Location will be further normalized into what? Location hierarchy. This is a dealer. This fact table is joined to this dimension table dealer. Now dealer table is again further normalized. Another again it is split into smaller table. Which are the tables it is split? It is split into location and country. Similarly, this dimension table is product. Now product is again divided into smaller table called as variant. So this is called as a snowflake schema. Very easy. Fact table is a fact table surrounded by multiple dimension table is star schema. Snowflake schema. This particular dimension table is further normalized. This particular dimension is further normalized. If the dimension table is further normalized, that is called a snowflake schema. Last and final is the galaxy schema. Here also the model resembles to a snowflake. That is why it is called a snowflake schema. Okay, this is fine. Next is galaxy. It is looking like a galaxy. So galaxy table, what happened? Galaxy schema, what will happen is, in galaxy schema, what will happen, guys? So you can see there's a fact table and it's joined with the multiple dimension table, and same dimension table is used by another fact table. So this is a fact table revenue. It is joined to a dimension table, branch dimension and date dimension. Again, this fact table product is joined to the branch dimension and date dimension. So if the multiple fact table is joined to the same dimension table, that becomes a galaxy scheme. So multiple fact tables are there, multiple dimension table. The same fact table is joined to multiple dimension table. Suppose this is a revenue fact table is joined to branch dimension and date dimension. Again, this is a fact table product which is joined to the branch dimension and date dimension. So that is called as galaxy schema. So this is resembles to a galaxy kind of thing. So that is why it's known as galaxy schema. There are two fact table which is joined to the same dimension. This product dimension product fact table is joined to the same dimension branch, and again this revenue fact table is again joined to the branch dimension. So this product fact table is joined to the date dimension, and again this revenue fact table is again joined to this date dimension. So this dimension table is joined 2 times to the different fact tables. This kind of schema is called as galaxy schema. After we have understood all these things, guys, now in snowflake schema, one more thing, guys. This dimension table and this dimension table is again joined using primary key and foreign key relationship. Next, guys, is the type of dimension and type of fact table. Now you can understand there is something called as confirmed dimension. So let us just go. See, this is a confirmed dimension, guys. So here you see, this is a fact table. This is like a galaxy schema. This is a time dimension. This is a product dimension. Now, this particular time dimension, let us focus here. This particular dimension table is what happened, guys. This is joined to what? Fact table, and this particular dimension table is also joined to this purchase fact table. Sales also and purchase also. So what happened is just like for understanding, you can understand opposite of snowflake. Snowflake, what happened? One fact table joined to multiple dimension table. Here what happened? One dimension table, it is joined to multiple fact table for your understanding. So that is what is nothing but your confirmed dimension. A particular dimension which is joined to multiple can be joined to multiple fact table. That is nothing but your yeah, confirmed dimension. Time is the best example. Product is also an example of confirmed dimension. A dimension which is used or more than which is used in more than one fact table is called as confirmed dimension. So that is what is the confirmed dimension. Okay. Next is guide is the chunk dimension. As I told you, in chunk dimension, what happened? We'll take the random attributes like flag and some textual values, which is not having any actual meaning. The dimension table is collected. So that kind of dimension is called as what? A particular chunk dimension. So in the chunk dimension, what will happen is, guys, suppose this order info key, order type, order status, order payment type, order category. This was not having any meaning. Okay, to a particular dimension, this kind of information will be collected in a particular dimension that is called as chunk dimension. And then next is, guys, this is sometimes only used role playing dimension. A particular dimension has two meanings. That means what? One location, a particular product is ordered at one location and then delivery is in another location. So that kind of dimension, that means a dimension which is having different roles, that is called as what? A particular role playing dimension, is very, very rarely used, but you should know at least the meaning of the thing, that a particular dimension which can be used in a which can act differently, that is called as what? Same dimension which can have different roles, that is nothing but your role playing dimension. Suppose order location can be one place and delivery location can be different. So this particular location is nothing but your role playing dimension. This is fine, guys. Next is degenerated dimension. As I have told you, these are the dimension which is in the fact table. Okay, this particular invoice number and all, which is in the fact table, but it is not having its own dimension table and all. So that is nothing but suppose your invoice number, it is in the fact table, but this particular invoice number is not present in any of the particular dimension table. So that is called as what? A particular degenerated dimension, a dimension which is only present in the fact table, but it is not present in any of the dimension table. That is nothing but a degenerated dimension. Next is, guys, the and the last topic is the types of fact table. So there is something called as additive fact. If fact tables which can additive fact means what, guys? On a high level, you will tell what fact which can use the aggregate function like sum and max. So that is nothing but your fact additive fact which can be added. Okay, so we can use the aggregate function like sum and max, like sales. We can use what? Sum and max function. Semi-additive means what? These are the facts where some of the fact we'll use aggregate function and not for the others, like your account balance. The account balance always keeps on updating. So what happened, guys, is we cannot use the sum because it always gives a total account balance. So we'll not use the sum function, but we can use max or mean. Any of the aggregate can be used, and all the aggregate cannot be used. That is called as what? Semi-additive fact. Non-additive facts, we cannot use any aggregate function like a ratio 3:5. We cannot aggregate such kind of things. That is called as non-additive fact. So additive fact, we can use like all the aggregate function like sum and max. Semi-additive, we can use some of the aggregate function like sum we can use, but max and mean we cannot use. So that is like account balance. So because account balance will always have the cumulative values. So we can use sum. We cannot use sum because it will not be useful. We can use max or mean. Non-additive fact, we do not use any aggregated function like ratio 3:5. Now, guys, if we give a more detailed explanation for types of fact table, so consider this is a fact table. Fact table is sales, and dimension table is your product, date, salesperson, and customer. So, guys, now if you take here, if I take a particular table, a particular type of fact table, that is nothing but your additive fact. Additive fact is a fact, guys, that can be summed up with any of the dimension table. Okay, So now we have to understand which is the additive and which is the not additive. So if I take the quality sold, okay, so this can be summed up with any of this particular dimension table. So this will be what? Additive fact. If I tell a semi-additive fact, so semi-additive fact will be what, guys? Like the quantity left, okay? So now this quantity left will be what? This semi-additive fact, because you know quantity left can be only summed up with the product dimension, okay? So only this particular, what are the quantity which are left for a particular product. So that will give a relevant meaning. But if I take a quantity left for a particular customer, for a particular salesperson or a particular date, or what is the quantity left, it will not give any relevant meaning. So this is called as what? A semi-additive fact, because it can be summed up with the product but cannot be summed up with customer, sales and date person. As I have given you one more example of semi-additive fact, like account balance. We can use max of the account balance, what we have minimum, but we do not need to add the account balance, because some of the account balance, because we already know the account balance will be given a total account balance which is left. Non-additive fact is like your GST. It is a percentage value or a ratio value which cannot be summed up with any of the dimension table. That is called as what? Non-additive fact. So you have to be very, very clean and clear with all these definitions. Type of fact table, additive fact, fact table, which can be aggregated or joined with any of the dimension table, like your sales. Semi-additive, what you have to tell, this can be aggregated with some of the dimension table, but not with all the dimension table, like your account balance. Next is non-additive facts, where no aggregate function can be used, ratio or percentage kind of thing. With respect to a particular diagram, you can tell, suppose our sales of sales table is the fact table. If I have to tell a additive fact, I will go with the particular quantity sold, and a quantity sold can be summed up with customer also, salesperson also, with the product also, date also. This is called as additive fact. If I take a semi-additive fact, then what will happen is the quantity left, it can be summed up with for a particular product only, how much is the quantity left, but for a particular date or a particular salesperson or for a particular customer, so this will not make any actual meaning. So this can be summed with only with this product. This is called a semi-additive fact. Non-additive fact like GST 18%. So this percentage ratio which cannot be summed up with any of the dimension, that is called as non-additive fact. Then we learned there is something called as galaxy schema, where there will be multiple dimension table and will join with the multiple fact table. One fact table is joined to the dimension table, and another fact table is again joined to that particular dimension table. So this is called as what? Galaxy schema. And then I told you star schema and snowflake schema. Star schema, one fact table, multiple dimension table. Snowflake table, what happened? One fact table, multiple dimension table, but these dimension tables are further normalized. After that, I told you how to do the analysis and how to join the tables. After that, I told you there is something called as what? We learned types of dimension table. One I told you is what? Confirmed dimension, where what happened? Same dimension table can be joined to any multiple fact table, like your time dimension can be joined to sales and also can be joined to purchase. This is called as confirmed junk dimension. I told you dimension which is consist of the flag kind of column which does not have any meaning and is kept in a particular dimension, that is called as junk dimension. Then I told role playing dimension is what? A dimension which has a different meaning. Okay, so same dimension acting as a different role, like location. So order location can be one plus and delivery location can be different. Next is the degenerated dimension. I told you, suppose invoice number which is present in the fact table, the dimension key column, but is not present in the actual dimension table, that is called as degenerated dimension. After that, I told you what is the difference between fact and dimension table. Fact is the measure value, dimension is the textual value. Here less column, more rows, less rows, vertical, horizontal. So here it is primary key, here it is foreign key, this is loaded first, this is loaded second. All these exact definitions I have already told you, and this completes your data modeling. Told you fact and dimension tables are always normalized tables, and this is the actual understanding of your dimensional modeling or modeling. Always you should ask that which particular dimensional model this project is there. Either it will be star schema, or it can be what, snowflake schema, or it can be galaxy schema. And then you have to join the fact table and the dimension table, take out your query, and whatever the outputs are, we'll get here, that we have to verify with the report. This is what is the thing we will use the fact and the dimension table. This completes, guys, your particular